Hey everyone, it's Justin again. In this lesson, we're going to be discussing the explicit and recursive forms, the two main ways to write sequence formulas. Must resist the countdown rhyme this time. The joke was so bad, it felt like a crime. Okay, let's just get started. By the end of this lesson, you should be able to distinguish between the explicit and recursive forms of a sequence. You should also be able to state the benefits and disadvantages of these two forms. First, we'll define the explicit and recursive forms. Then we'll discuss advantages and disadvantages using previous examples. And finally, we'll do an example of distinguishing between these two forms. Sequences are often written in either explicit form or recursive form. The explicit form of a sequence uses only numbers and the variable n. With this form, you can jump to any term in the sequence. For example, these two sequences are in explicit form. Notice that they're defined by a formula for a sub n that only involves numbers and the variable n. Recall that we were able to substitute any number that we wanted when our formulas had only numbers and a variable. For example, if you want to find the 50th term in a sequence, you could just substitute 50 for n. Feel free to pause now if you want to take a look at this more. The recursive form of a sequence relies on at least one previous term to find the next term. It always contains the notation for a previous term, such as a sub n minus 1, a sub n minus 2, etc., and provides at least the first term, such as a1, a2, etc. For example, this sequence is in recursive form because its formula uses the previous term. It also specifies that starting term. Here's a second example, the Fibonacci sequence. Remember, a sub n minus 1 is the previous term, and a sub n minus 2 is the term before that. We previously discovered that a formula including a previous term has to go one at a time, and it's harder to find values further in the sequence using it. You might be wondering then, what good is the recursive form? Well, suppose you were writing a formula for this sequence. How would you do it? You'd probably see that you start at 1 and then just add 2 each time. And the recursive form above says exactly that. It's usually a lot easier to write down the recursive formula than it is to write the explicit formula. We'll continue this thought and start writing our own formulas in the next lesson. Let's summarize. The explicit form uses numbers and the variable n, and the recursive form uses at least one previous term, such as a sub n minus 1. The explicit form does not require a starting term. The recursive form, though, requires at least one starting term to use. The explicit form is super helpful for finding any term in the sequence, and the recursive form can only move one term at a time. It's a little bit harder to write the explicit form of a sequence, but the recursive form is super helpful for writing formulas from patterns. Let's do an example of distinguishing between these forms. Determine whether the following sequences are in explicit form or recursive form. For each example, make sure to pause if needed and see if you can determine which form it is. This one is in recursive form. This is because it has a previous term in the formula as well as a starting term. Let's do another. Remember to give it a try, pausing the video if you need. This one is in explicit form. It's because the formula only involves numbers and the variable n. Last one. Which form is this one? You might have struggled a little bit with this one because it doesn't seem to have any of the characteristics we've discussed. Truth be told, it's neither of them. We could make an explicit or recursive formula for this sequence, but this is just the sequence written as a list of numbers. Now you can use sequence forms. Remember that the explicit form gives you a formula with numbers and the variable n. It'll let you find any term even if you don't know the term before it. The recursive form gives you a formula that's only useful if you know the previous term, but it's great for writing a formula for sequences with patterns. Next time, we'll start learning how to identify patterns in order to write a formula for a sequence. See you then!
Hey!